Hello everyone. Today we are going to solve the fourth problem of Leetcode Weekly Contest 332, which is subsequence with the minimum score. So we are given two strings S and T. We are allowed to remove any number of characters from T, and our score will be like the first deleted characters and the last deleted characters and the number of characters between them. So if the first deleted character is at left index and the last deleted character is at right index, then our score will be right minus left plus 1. Now we have to minimize the score. Okay, so let's take this example ACABA. So let's take this example. The AC is equals to ABA CABA. ABA CABA, and what is the T? T is nothing but BZA. So T is BZAA. So as you can see that if we remove this z, then ba is present in the s as subsequence. So this b, a and a is present as a subsequence. Now what is the left index we are removing? The left index we are removing is 1 because we are using zero based indexing, and the right index we are removing is also 1. So our r minus l plus 1 is 1, so the answer is 1. And in the second case you can check that xyz is not present in s, so we are deleting all the three characters, so our answer is 3. Okay, L is 0 and R is 2. So I hope you got it. Now for solving this problem, one like the thing you like need to know, like how to, like you can read this article. Given two strings, find if the first string is a subsequence of second in order of n. Okay, this is quite easy because the difficulty level is also easy. So let me go through this how we can do that, go through this algorithm. So let's take this example. Let's say ABA CABA is our string, first string, and the second string is, let's say, AAA. Now we want to find if the first string, like the second string, is subsequence of the first string. So for this let me write the algorithm, the pseudocode for this. So we'll just initialize two variables. uh, mm, so initialize two variables, I equals to 0 and j equals to 0, and the length of the first string is n. So we'll do like while I less than n and j less than m. Okay, now we'll do something like mm, if si equals to tj, we'll increment the value of I and j by 1, I plus plus j plus plus, else we'll just increment the value of I by 1. So this is quite straightforward. So let me go through this how it is happening. So let's say I will point to this character first and j will point to this. So si equals to a and tj equals to a, so both are equals to same. So we'll just increment both I and j by 1. Now I will move to b and j will move to a. So si not equals to tj, so we'll just increment I by 1. Now again si equals to a and tj equals to a, so we will increment both I and j. So again si equals to c and tj equals to a, so we will only increment a. Now this si and tj are equal, so we will increment I and j both. Now j is equals to m, so we will just break. Now if j equals to m, we will return true, else we will return false. Okay, I hope you got it. Now we will use this algorithm. This algorithm will be used to solve the problem. So let's say, let me write one thing. If we write something like, if we store the value of something is here. Okay, so let's say we are storing prefix j equals to I. So before incrementing I and j, we are just storing prefix j equals to I here. So how this is going to help us? So let's say what we do, we'll just find if we want to have prefix j as a subsequence of s. If we want to have prefix up to j of t. Okay, sorry, let me delete this. So let me write it, prefix j equals to I. Now let's say we want to have t index up to j as a substring of us. Okay, a substring of s. So what is the minimum index? What is the minimum index that we can have? Okay, so let's say s up to I has a subsequence of t up to j. So we want to just find this I value for every j. Okay, so let's say for this for the first character, for the prefix of index 1, the I will be 1. For prefix of index 2, I will be 3. For prefix of index 3, I will be 5. Okay, I hope you got it. So the value of prefix will be nothing but 1, 3 and 5 if we are using one based indexing. I hope you got it. Now let's take another example. So let's say A B C B C A, and another thing is B A A. Okay, so for index of 1, so if we just consider the prefix of T of index 1, the value will be 2. Okay, the so prefix array, we are just building prefix array, so it will be 2. And for BA, the index will be nothing but 1 2 1 2 3 4 5 6, it will be 6. And for BA, the value will be 7, because for B this is the first, now for BA this is, and for BA this is. I hope you got it. Now similar thing we can do for suffix. Okay, now the similar thing we can do for suffix. So let's say for say build the suffix array for this one. Let's say ABC BCA and BA. We'll do the same thing for suffix. So for the suffix this A, for the suffix A, what is the minimum length suffix? The minimum length suffix is A. For this A, what is the minimum length suffix? The minimum length suffix will be A. And for this BAA, what is the minimum length suffix? The minimum length suffix is 4. Okay, so what is our desired suffix array? The suffix array is nothing but we'll just store the index. So for the last one, the index is 7. For the second one, the index is 6. And for this, let's say for this, the index is 7654. So this is 467. So we will just build the prefix and suffix array. So the overall complexity will be order of n and plus order of n. So this is order of 2n. Now there comes the interesting part. How will we solve this problem? Now we know for the ith character, let's say for we know for the ith character what are the index, like up to what index it is required to have this prefix. Okay, so let's say let's take this example only, ABA CABA. So let's take let's delete some of the things from here. Now let's say for this ABA CABA and BZA BZA. Now we know for building this prefix, the minimum prefix required is here 2, and for building this suffix, minimum prefix required is here is this one. Okay, so we'll just delete this thing from here. Okay, so for every index I, we'll just find out, let's say we have prefix I, let's say prefix I, we'll just find out the minimum j, such that suffix j greater than prefix I. So for every index I, we will just find out the minimum j where suffix j greater than prefix I. So for B, the index is here, the index of B is 0 and the index of A is 2. So our answer will be 2 minus 0 minus 1, 1. Okay, I hope you got it. Now let's take another example. Let's consider ABA CCBA, and our character is CBC. Okay, CBC. Okay, now for C, the minimum prefix required here is 4. Okay, and for CB, the minimum prefix is required here is 4 5 6 4 6. And for CBC, there is no prefix is efficient, so we can mark it as infinity, or we can mark it as n plus 1 or anything. So this is our prefix array. And for suffix array, C is nothing but 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. So this is C is 5. For CV, this is again you can say it as minus infinity and minus infinity. I hope you got it. Now for this 4, we'll just find out what is the minimum index R which is greater than prefix I. So 5 is greater than prefix I. Okay, so for index 0, the our index will be 2, so our answer will be 2 minus 0 minus 1, which is 1. I hope you got it. Now let's jump into the code. So here we are doing building the prefix array, as I explained, prefix and suffix array. I have explained it here. You can also check the GFG blog here. I will give the link of the GFG blog in the description box. So after building the prefix array, we are just initializing answer by bisect left suffix comma 0. As you can see, instead of defining all the variables by minus infinity, we are using minus 1, because minus 1 will also be sufficient for us. So so what is the initialization part here? Initialization part is also important. So why we are initializing our answer with suffix? So as you know, bisect left is nothing but binary search in C++. So lower bound, you can say. So we are just finding lower bound of 0 in suffix, because we are initializing everything by minus 1. So let's say this value is 0. Then if we only delete this prefix from the index b, then we'll find the subsequence. Okay, so the answer will be initialized with 3. Okay, I hope you got it. Now as you can see, if prefix I equals to n, because we are initializing prefix by n, so if prefix I equals to n, we are just breaking. Else we will declare suffix I equals to minus n. Why it is required here? Because our suffix I is an increasing array. So suffix I is an increasing array. So when we are at index I, we just want to find all the indexes greater than I. Okay, let's say there is some index j which is lesser than I, and suffix j greater than prefix I. This is not required. Okay, so that's why we are marking all the suffix j which is less than equals to I as negative infinity or negative n. Okay, I hope you got it. Now we are finding r equals to bisect left of suffix comma prefix I plus 1, or lower bound, you can say. As I have already told, we want to find the minimum j such that suffix j greater than prefix I. That's what we are doing, and we are storing answer as minimum of answer comma r minus I minus 1. So this problem is quite interesting, and the explanation could be like vague sometimes. So what you can do, you can go through this video more than once if you are not understanding the concept, or you can write in the comment section that what part of the video you are not understanding. I will provide the link of the code in the description box, also the GFG article. Please like this video and subscribe to my channel. And for other videos, please stay back. I will post the CB editorial also. So please like and subscribe. Thank you.